Hello! Today we're going over 10.2 measures of variability. Yesterday we went over measures of center, which described where the center of your data set was. Today we're going to go over the variability, which you can see here on the slideshow. It describes the distribution of the data. So some words that you need to know are one of them being quartiles. And when you hear quartiles, you hear the word quart, which is like quarter. So it's the values that divide a set of data into 4 equal parts. So there's 4 quartiles in a set of data. Your first quartile is the median or the middle of the lower half of data. And the third quartile is the median or the middle of the upper half of the data. So in order to figure out your first quartile, you first need to figure out your median of your entire set of data. Then you take the bottom half and find the median there. And same for the third, but using the upper half of your data. So for example, in this data set, I have 3 different points labeled. You know that the center is your median. On this previous page, it said the first quartile is the median of the lower half of the data. So we're going to look here into our lower half. The middle of our lower half then is the first quartile. Sorry, that is illegible. And so then up here, the middle of our upper half is the third quartile. So you have your first quartile, your median, and your third quartile. And that splits everything into 4 equal parts. We also have a word that you guys recognize that we're kind of upset that we didn't go over yesterday. That's the range. So your range is a measure of variability, not a measure of center. And what the range is, and you guys know it, it's the difference between the greatest and least values in a set of data. So it's your largest number minus your smallest number. And then your interquartile range is the range of the middle half of a set of data. So it's the difference between the first and the third quartile. So you take your third quartile minus your first quartile to get your interquartile range. Sometimes it's just written as your IR. So what we want to do here is find the measures of variability for the data in the table that's given here, which is the U.S. Summer Olympics silver medals from 1976 to 2008. So the first thing that you always want to do is put this data in order. So I've got 0, let's see what else, 24. And notice how I'm crossing them off as I write them down so that I make sure to get every single number. So our range is our biggest number minus our smallest number. So right away I go 61 minus 0, that's 61. So our range is 61. Now our median is the number that's in the middle. So I'm going to go and get everything down to what our middle number is here of 34. So then our first quartile is the number that's in the middle of the bottom half of our data. So I'm between 0 and 34. So I start crossing them off, and 31 ends up as our first quartile. Third quartile is the middle of the upper half. So we're going to find the median there and end up with 38. And you can see with the dots on the screen where I'm crossing off these numbers. To figure out our interquartile range, we see here it says the third quartile minus the first quartile. So if our third quartile is 38 minus our first quartile of 31, that gives us an interquartile range of 7. So we're figuring out just the median of the bottom half and the median of the top half, and then the range between those 2 points is really the only new thing that you're learning here right now. So I want you to go ahead and pause and try this part on your own, and then compare with what I come up with. So the things we need to know are range, median. I'm going to start shorthanding things here. Our first quartile, our third quartile, and our interquartile range. Those are all of the things that are included in our measures of variability. So just like our measures of center were mean, median, and mode, measures of variability are range, median, first quartile, third quartile, interquartile range. So like we did earlier, we got to put these in order. 25, 40. Oops, I missed one. That's why we cross off. 29, 25, 39, 40. There we go. And I missed one in there again. 25, 38, 39, 40, 44, 45, 49, 53. Okay, that was harder than it should have been. So first things first, our range is our biggest minus our smallest, so 53 minus 25. And you end up with 28 as a range. So our range is 28. Our median is the number in the middle, so we start crossing these off. And I end up with 40 and 44 in the middle. So what I do is I add those two numbers together to get 84, and then I divide them by 2 and end up with 42. So the number in between 40 and 44 is 42. So our median is 42. So in this set of data, we're not given things exactly perfect. We're having to figure out things on our own. So now we need our first quartile. And our first quartile is the number that's in the middle of our top half of data. So what we need to do is we'll just start from 40. So we hit our 40, we hit our 25, and 38 and 39 end up in the middle. The number that's in between 38 and 39 is 38.5, and that's something we just know. So then in this top half, we start cross off 44, 53, and we end up with 45 and 49. The number that is in between 45 and 49 is 47, because you've got 46 going up 1 from 45, down 1 from 49 to 48, and then 47 stuck in between there. And our interquartile range is 47, our third quartile, minus 38.5, our first quartile, to give us 8.5. So those are the 5 pieces of information you need to know for the measures of variability in this problem. So here we have a word that you guys recognized, but there's more of a specific definition than you've known in the past. It's called an outlier. And you know an outlier is a number that's like way crazy far away from all of the rest of the information. But to be specific, your outliers are data that are more than 1.5 times the value of the interquartile range beyond the quartiles. Okay, I know, crazy, so much quartile words, and like this definition is more complicated than it needs to be. So basically what it's saying is you, step 1, need to figure out what that interquartile range is. Step 2, you're going to multiply the interquartile range by 1.5. You're going to take whatever that number is and subtract it from the first quartile. And then also add it to the third quartile. And then if that number is outside of whatever you end up with here, it's an outlier. So when you figure out what these two numbers are in step 3, if a number in your data set is smaller or bigger than whatever numbers you come up with, then that means that you have an outlier. So in this set, step 1, we need to figure out our interquartile range. So we need to take our numbers, and looking over here, it looks like they're in order. So we don't have to change that, but we need to figure out our first and our third quartiles so we can figure out what that interquartile range is. So first we need to figure out our median. So I'm going to do. Our median is 30. So then I need to go from here and figure out our first quartile. So boom, 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 boom. I need the number that's between 15 and 25. And that would be 17.5. So 17.5 is our first quartile. Then here, 30, 70, 32, 35. The number that is in between 32 and 35 is 33.5. To figure out our interquartile range, we take our third quartile of 33.5 and subtract that from our first quartile of 17.5. And we end up with an interquartile range of 16. Up here in step 2, it says to multiply the interquartile range by 1.5. So we need to take 16 and multiply that by 1.5. And we end up with 24. We're on to step 3 here, where we subtract that number from the first quartile and add that number to the third quartile. So if our first quartile was 17.5, we're subtracting 24 from it. And you're allowed to use calculators here. I'm not going to pick on you for that, but make sure it is an actual calculator, please. We end up with negative 6.5. Then we need to add that to our third quartile. So we have 33.5, and we need to add 24 onto it. And we end up with 57.5. Now, in order to have an outlier in our information, that number needs to be either smaller than negative 6.5 or larger than 57.5. Our smallest number is 12 in this data set, so our outlier isn't on that end. The biggest number is 70. 70 is bigger than 50, so our outlier is 50. Always double check the next number too, just in case there are multiple outliers. 35 is not greater than 57.5, so our outlier is just 50. Now I want you to pause and try finding the outliers on your own, and then you are welcome to compare with whatever I get when I solve it. So here's all of our pieces of information. The first thing you always do, put them in order. So 96. Let's see if I do better this time. 100. 105. 110. 115. We've got 120 twice. And 155. So let's get our quartiles. Boom, 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 boom. Between 110 and 115. So our median's right in here. First quartile, The first quartile is 102.5. Because halfway between 0 and 5 is 2.5, and then you just add the 100 onto it since we're working in the hundreds here. And over here, 115, 155, What's between 120 and 120? Well, guess what? That's 120. So now we need our interquartile range, which is 120 minus 102.5, which I believe is 17.5, but I just want to double check. Yes, it is. So our interquartile range is 17.5. Step 2 is to multiply that number by 1.5. So 17.5 times 1.5 gets us 26.25. As I write that wrong. 26.25. Then we subtract that number from our first quartile. So we take 102.5 minus 26.25 to get us 76.25. And then we take 120 and add on the 26.25 to get us 146.25. Do we have any numbers smaller than 76.25? No, our smallest number is 96. Do we have any numbers bigger than 146.25? Yes, we do. So we have an outlier. Our first one would be 155. Then always double check that second smallest number. This one's 120. That's not bigger than 146.25, so our only outlier is 155. Here it says the table shows calories burned by each activity and use measures of variability to describe the data. So we're going to do more than just figuring out what these numbers are. We're going to explain them as well. So we still want our range and our median and our first quartile and our second quartile and, not our second quartile, our third quartile. Sorry, that first is really hard to read. And our interquartile range. And we also want to know if there are any outliers. So right now, I'm going to just trust that you're able to figure this out for the sake of time here in our lesson. So our range is our biggest number minus our smallest number, which gets us 177. Our median is 216. Our first quartile is 166.5. Our third quartile is 231. So our interquartile range is 64.5. In this case, we have one outlier of 84. I believe. Let me double check. Now I'm second guessing myself and I apologize. So in order to check this, I'm taking 64.5 times 1.5 and getting 96.75. And I'm going to take 166.5 minus 96.75 and we get 69.5. So I stand corrected. There are no outliers in this data set. Just because 84 seems like it's far away, that makes it an extrema, but it doesn't necessarily make it an outlier. And so you want to always double check to make sure that you don't make a mistake like I almost did. So now we want to describe this. So this part you need to make sure you are listening. So I'm going to put a little star here. Listen to what I'm saying because I'm not going to write it down because it's not going to be legible for you. So with all this data, we want to be able to describe. So we know this data is the number of calories burned for 30 minutes. So what you can say to describe this is you can say in 1/4 of the activities, you will burn 166.5 calories or less. because the first quarter of our data right here is 166.5. In 1/4 of the activities, you will burn 231 calories or more. And it's 1/4 of the activities. I think I just said third. So 1/4 of the activities, you will burn 231 calories or more. So from that third quartile up is 1/4 of your information. And the number of calories burned for half of the activities is in the interval of 166.5 to 231. So it's in between those numbers. And remember, just because it says third quartile, up here, we are split into 4 chunks. So this is your first quartile here, so that's 1/4. I'll highlight it. So this is 1/4. Up here, from your third quartile up, is 1/4. And then you have all of this, if it'll let me, all of this in between. And that's 1/2 of your data. So your interquartile range there is 1/2 of your data. From third up is 1/4, and from first down is 1/4. Finally, we have a little multi-step question here for you. We're kind of finally pulling everything together. So here it says the number of counties for certain western and northeastern states are shown. It wants us to compare the western states range with the northeastern states range. So all I'm going to do here is find our smallest numbers and our biggest numbers. And looking at this data, guess what? We're lucky. It's in order. So the western, I don't want to write in highlighter. The western states range is 56 minus 15 to get us 41. The northeastern states range is 62 minus 3 to get us 59. So comparing these two, here's your listen moment. We would say the range of the northeastern states is greater than the range of the western states. That was an easy first step. Let's go on to step 2. It wants to know, do the data for either region contain an outlier? So going back here, I'm going to actually try to copy paste this. I don't think I can. Darn. Oh, yes, I can. Copy, paste. So boom, we have it on this page. We want to figure out if they have outliers. So first things first, we need the western states interquartile range and the northeastern states interquartile range. So we'll start with the western, find our median, top, bottom, top, bottom. It's in between 36 and 33, which would be 34.5. That's not the interquartile range though. Oops. That's just the median. Then we have to figure out our first quartile. Quartile 1 is 23. The upper quartile here, the third quartile, is 44. Our interquartile range is the third minus the first, so 44 minus 23 to get us 21. Then we're going to do this again up here, and you can, since we have the same amount of numbers in both of our data sets, our first quartile will be in the exact same place as our previous set, as well as our third quartile. So we've got 21 and 8. 21 minus 8 gets us 13. Yes, 13. So that's our interquartile ranges. Step 2, after you figure out the interquartile range, is to multiply those numbers by 1.5. So we're going to take 21 times 1.5 to get us 31.5. Same thing with our other piece of information. 13 times 31.5, or not 31.5, 13 times 1.5, sorry, to get us 19.5. Then we need to take whatever numbers we got, subtract them from our first quartile, and add them to our third. So for our western states, our first quartile is 23, and we're going to subtract 31.5. So we've got negative 8.5 going up to our third quartile is 44 plus 31.5 to get us 75.5. Looking at that data, 15 is our smallest, 56 is our biggest. So there's no outlier for the western states. For our northeastern states, quartile 1 is 8 minus 19.5 to get us negative 11.5. And then we're going to take 21 plus 19.5 to get 40.5. So our northern states have an outlier of 62, because 62 is greater than 40.5. So yes, our northern states have an outlier, and no, our western states do not. And finally, it wants to know, how does the outlier affect the measures of center for the northeast region? So we need to figure out, number one, we're going to paste our information back here. Now we only care about the northeast. Our measures of center are all of our M words. So mean, median, and mode. And what we're going to do is figure out our numbers without the outlier involved and with the outlier. So our median without the outlier is adding up all of our numbers except for 62. So we'll have 3 plus 5 plus 8 plus 10 plus 14 plus 14 plus 16 plus 21 plus 24 to get 160, and then we're going to divide by how many numbers we just used. So 2, 4, 6, 8, 9. So our mean without an outlier is 33. Our median, not including the outlier, is 14, and our mode is 14. Including our number 62 here, our outlier, our mode will not change. So our mode is still going to be 14. But I think everything else might. We'll see. That's my prediction. So to figure out our mean, we're going to take our 160 and then add 62 onto that to get 222. What we also do now is divide by 10 instead of 9 because we're including all of the numbers. So our mean, including the outlier, gets us at 22.2. And our median then is between 14 and 14. So our median then would be at 14. So how does the outlier affect our measures of center for the northeast region? Well, it doesn't change much with the mode and the median. So that's why we usually pick the median when there's an outlier or an extrema in our data set. But what does it do to our mean? It actually made our mean smaller. So including our outlier in the information, our mean got smaller than it did not including the outlier. So we are done with our PowerPoint here. I hope you got a little bit of practice using our quartiles and our interquartile ranges and calculating our outliers. And you are on to your homework for today. Good luck. I can pause that.